Welcome to synthetic division and zeros. So how are we going to use synthetic division to solve polynomial equations? And I guess first of all, what is synthetic division? You're actually going to like this. Synthetic division, though, we have a little bit of rules we need to know. It only applies when you have the divisor, that's the thing on the outside, in the form x minus c. So it could be something like x minus 2 or even x plus 5. The idea is you have an x or some variable plus or minus a number. If you have an x squared or you just have a number or something, then that's not going to work. It has to be in that form. The other thing is it has to have every descending power of x has to be in there. So we're going to go just like we did on the long division. You start at the highest power, and if you're missing anybody, you put zeros in for them. And we're going to use nice, neat, tidy columns. So it's going to be some fun with keeping things in the perfect, beautiful lines, and it'll be great. So here is what we're doing with synthetic division. First of all, we need to check to see, is this in the form that we want it in? We have x minus a number, basically. And yeah, it could be even plus. It doesn't matter. It could be plus or minus there. But we have an x and we have a number with a plus or a minus sign in between it. So we can now say we can use synthetic division. The other thing we need to do is we need to make sure that every single one of our highest power down to the lowest in order in the problem is there. So we've got fourth power. Oh, it's missing a cubed. So I'm going to put 0x cubed in for him. Then comes squared, then comes first, then comes the number. Okay, so now he's okay. I fixed him. Now here's where it gets fun. We draw the big L for synthetic division, and then I put a little bitty basket down here to catch the remainder in. Now, what am I going to do first? Whatever this is, x plus 2, I'm going to change the sign and drop the x. So if it was x minus 5, I'd put a plus 5 out here. So I change its sign because it only wants c. And then across the top here, I'm going to put each of these guys in order without the x's. So I had 4x to the fourth, so there's a 4. I had 0x cubed, so there's a 0. I had negative 2x squareds. I had negative 1x's. And then I had positive 1. So each of them gets a nice, beautiful column. And the last one is going to be over my basket. Now that I have everybody in the right place, I'm going to start my synthetic division. It's kind of like regular division. It's just in a kind of different order. The way it works is you bring down your first number to the bottom row. Every time, bring him down. Then you take whatever's on the bottom row and you multiply it by the outside. So 4 times negative 2 is negative 8. It goes on the next row. Then you add the column together. 0 plus negative 8 is negative 8. And then repeat the process. Multiply the bottom by the outside. So negative 8 times negative 2 is positive 16. Add the column. Negative 2 plus 16 is 14. Multiply by the outside. 14 times negative 2 is negative 28. Add the column. -1 and -28 makes -29. Multiply the outside by the bottom. -29 times -2 is +58. Add the column. 1 plus 58 is 59. And now that I've made it to the end, I can finish and write my answer. So a couple things we need to know now that we're at the end. The box is always the remainder. Then we go and we start with our lowest exponent and work our way up. So this right here is just the number. This is x to the first power, x to the second power, x to the third power, and we would keep going if there were even more columns. And then now, here's how you write your answer. In this one here, I have 4x cubes. Here, I have -8x squareds. And 14 x's. And the number is -29. Now here's the hard part. Remember, if you have a remainder, you add your remainder over what you divided by. So this here in black is my final answer with synthetic division. Now you could do this with long division of polynomials like the box method, but I think synthetic division, if it's ever in this form right here, x plus or minus a number, much faster, trust me. When you get the hang of this, you'll be fast at it. Now, there's this thing called the remainder theorem, and this looks like a bunch of math language here. It says if a polynomial is divided by this divisor x minus k here, the remainder is going to be f evaluated at k. So you got to take a little bit of trip back to Algebra 1. You had some f of x. We'll say it was, 3x plus 2. And somebody asked you a question such as, what is f at -3? And you learned that what you do is you take that number that's in the parentheses and you evaluate by substituting it in for all the x's in the problem. And then you get a number out. 3 times -3 is -9. -9 plus 2 is -7. So what they are saying is that whatever this number here is, if I'm doing the long division, synthetic division, that's also that same number that's out here. That's what they're saying. And they're saying that this answer, -7, goes here as the remainder. So let's practice it. So I'm going to use synthetic division because what it says here is it wants me to find f at 1 for this polynomial. Now I did say that what we could do, and I'm going to practice that real quick, is I could plug 1 in for all the x's in the problem. This is like you would have done in Algebra 1. So I'm going to say 1 cubed minus 2 times 1 squared minus 4 times 1 plus 1. That's 1 minus 2 is -1. -1 minus 4 is -5. -5 plus 1 is -4. So I'm telling you the answer is -4 using Algebra 1. But what we're going to do is we're going to do this with synthetic division. And what we're going to do is we're going to put on the outside this 1. And when we get done, we're hoping that our remainder is going to match and be -4. That's what we hope. So I'm going to go across the top here. I've got cubed, squared, first power constant. Nobody's missing and it's in order. So I'm going to put 1x cubed down, -2x squareds down, -4x's, and the number 1. And remember, we're going to follow our steps. You bring down the first number, multiply it by the outside, so 1 times 1 is 1. Add the column, -2 plus 1 is -1. Multiply by the outside, so -1 times 1 is -1. Add the column, -4 and -1 make -5. Multiply by the outside, -5 times 1 is -5. Add the column, 1 and -5 make -4. Look at that! That is the answer. So F at 1 is the same answer if I put 1 into synthetic division. Now, you might say, well, those both took a little while to do. Synthetic division with big numbers is going to be faster than the evaluating, what I did in yellow up there, like Algebra 1. But in these small ones, it wasn't real hard because 1's not a big number. But if you're doing big numbers, synthetic division is going to be faster. Now, there's this thing called the factor theorem. He says if we have a polynomial, it has a factor. Factors are usually the things in parentheses. And this here is called if and only if, we abbreviate it IFF. You probably learned that in geometry. Only if our answer is 0. So that means, is our remainder going to be 0? Then it's a factor. So we just need to know if the remainder is 0, it is a factor. Any other answer, not a factor. So let's practice that idea. We want to show that x minus 1 is a factor of our polynomial. So that means when we do synthetic division, we want a remainder of 0. So I'm going to draw my synthetic division. Now this guy up here says x minus 1. Since he has the x, remember we changed the sign and put him out there. Now this, we make sure everybody's in order from highest to lowest exponent. We got fourth. Oh, there's no cubes. There's no squareds. There's no x's, but there is a number. So I'm going to put these across the top row. 1x to the fourth, 0x cubes, 0x squareds, 0 x's, and then a -1 for the number. Now I'm all set to do my synthetic division. And remember, we are hoping that this remainder is 0. So I start by bringing down the first number, multiply by the outside, 1 times 1 is 1, add the column, 0 plus 1 is 1, multiply by the outside, 1 times 1 is 1, add the column, 0 plus 1 is 1. It's kind of boring, there's a lot of 1's. Multiply by the outside, 1 times 1 is 1. Add the column, 0 plus 1 is 1. multiply by the outside. 1 times 1 is 1. Add the column. -1 plus 1 is 0. Yes, he is a factor. Yes. So let me go back one. So